Oh, doop, de-doop, de-doop, de-doop. I think you really want to talk about deduplication here, don't you, Wes?
I think so.
I think I'm just going to kind of dedupe my way out of here and let
All
you
right.
have the screen, all right?
Yeah, we're just going to run through a very simple overview of the deduplication process for Veritas file system. So, what I have is Brad. Brad's our manager, never happy, so frowny face. This is Bob, always upscale, upticked up, whatever you want to talk.
I'm happy, man.
You're
I'm
a
just
happy man.
Again. That's it.
Okay, so here's Bob, and here's me, just cheesy. All right, so let's say Brad, our manager, has a PowerPoint, big old PowerPoint that he sends to us via email, and we save it on our systems, saves to our server. And that PowerPoint is 100 megabytes in size. Okay, so we're going to represent the PowerPoints with these little quads right here, and say they're all the same. So I have 100 megabytes here, 100 megabytes here, 100 megabytes here. So that gives us a total of 300 megabytes of disk space being utilized for 3 copies of the same file. Well, if we have the dedupe process, the dedupe process configured, and it is a schedule-based deduplication engine for Veritas file system. And there's typically 2 types of deduplication, file-based or block-based, and VxFS actually does both. We do block-based, based on chunk size. So it's 4K to 128K, 2K increments. You get to set it when you're configuring this. And if a file is actually smaller than your chunk size, then the deduplication is done based on the file itself. So as the dedupe engine scans through the environment, based on the chunk size, each chunk size will be fingerprinted, and the data that's developed from that goes into a deduplication database that's in the lost and found directory for that file system. And then they're compared to each other to find blocks or chunks that match. If they match, then we'll retain a single copy of it, and all other copies will be expunged, and pointers will go into place and point to the original blocks, thus saving disk space. So we scan through this, we see them all the same, and we see each quadrant here, A, B, C, D, is the same in each one. So we are going to dedupe A, B, C, and D. We're going to keep 1 copy of each of those. So we'll say, here's our 1 copies. We're going to take all of these to 0, which means this goes down to 100 megabytes. Whenever we read these, we're actually pointing to the same block and get our data. Okay, so we saved a significant amount of space there. But let's say Bob goes in here, and he likes the presentation, but he wants to change a few things. Turns out he's going to change a lot, because he's going to go in here and change 1 whole quadrant, say 25% of this. Well, that's new data, and it's not dedupe, because we haven't run the dedupe engine yet. So we've got now 25 megabytes associated to this PowerPoint presentation. So now, because he made these changes here, we've gone to 125 megs for this particular set right here. So now I look at this and I love what Bob did. I said, Bob, send me your PowerPoint. So Bob sends me his PowerPoint. Now I have it, and I replaced my original one there. So now I have 25 megabytes associated to this. This goes to 150, okay? Because we haven't run the dedupe yet. On the next scheduled moment that the deduplication engine runs, it scans through here and determines, 1, B is no longer multiples, so we no longer need to dedupe B, but we now have 1 that is now multiples. We keep 1, we add pointers to the other one, and now 1 will be deduped. Nothing has changed with A, multiple copies. Nothing has changed with C. Nothing has changed with D. So because we had this 25 here, we dedupe this, we lose this, we go to 0. We're now back to 125. And there we have it.
And that's how it all works, right?
Pretty much.
It's pretty straightforward.
It's a huge space-saving tool.
Fantastic.
If you have a lot of data that is the same. So virtualization environments where you have a lot of virtual machines that have 90% of the virtual machine is the same from VM to VM.
Yep.
Huge savings here.
It is.
So wonderful, wonderful tool.
Well, let's hope that no one wants to duplicate this video and it just gets deduped. How's that? Thanks, Wes.